This video is brought to you by MathGalaxy.com. This is a review of whole number addition. All of arithmetic is basically about counting things, and it's based upon the base 10 system. So you have ones, groups of tens, 10 tens give you a group of 100, 10 hundreds give you a group of 1,000. The only things that are arbitrary in the system that you need to memorize are single-digit addition and single-digit multiplication. By arbitrary, I mean that the symbol to represent a particular number is arbitrary. This symbol 4 means 4 things. The other numbering systems have different symbols. The Mayans had a base 20 system because they were counting fingers and toes. The Babylonians had a base 60 system, which is the basis for our time measurements, 60 seconds in minutes, 60 minutes in an hour. If you remember as a kid, you used tick marks. If you got to 5, you would put a slash across 4 tick marks. Some civilization used knots tied in ropes. Each of these numbering systems had its own symbols to represent quantities. So the Mayans, the Babylonians, the Chinese, each had different symbols to represent 4. Roman numerals used IV. So in that sense, the numbering systems are arbitrary. And likewise, in our numbering system, adding single-digit numbers, the symbols are arbitrary. But beyond single-digit addition and single-digit multiplication, which have to be memorized, everything else is based upon logical rules. As an example, once you memorize that this symbol means this number of things and this symbol means this number of things, then to add them, you could count up to the next 10. 8 plus 2 of these get you to 10, plus 2 more get you to 12. As another example, once you memorize that this symbol means this number of things and this symbol means this number of things, again you can count up to 10. 6 plus 4 of those, 7 gets you to 10, which leaves 3 more, or 13. Or you can go to the number line. So you can count over 7, and then 3 more get you to 10, and then 2 more get you to 12. Once you memorize single-digit addition, then the next major concept is regrouping. So here, starting with the ones, 8 plus 6 is 14, plus 9 is 23. So we have 3 ones, and the 20 becomes 2 groups of 10. So those are our 2 groups of 10. Next, adding the tens, 2, 4, 9, and then 7 is 16. So that gives us 6 tens, and 10 of those tens becomes a group of 100. So now adding the hundreds, we have 4 plus 7 plus 5 is 12. So that gives us 2 hundredths, and 10 of those becomes a group of 1,000. Our philosophy is that students will eventually be using calculators for serious work. So arithmetic is about learning the nature of the number system. The speed and shortcuts can come later, but it's about learning basic concepts that will carry over to fractions, decimals, and algebra. One way to understand our system of counting is to look at alternative procedures, in this case for addition. For example, the partial sums method does each size separately. So for example, if you add the ones column, 5 plus 4 is 9, plus 7 is 16. Now for the tens column, we have 8, 2 is 10, so we have a total of 11 tens. So that's 11 with 1 0. And the hundreds, 2 eighths are 16, plus 5 is 21. And since it's hundredths, we add 2 zeros. and then you add all the partial sums, 2, 2, 2, 6. And here with 4-digit numbers, so 9 and 6 are 15, 8 and 7 are 15, so that's a total of 31s. Now tens, we have 2, 5, which is a 10, 19, and 23. And so these are tens, we add a 0. Now hundreds, 10, 15. So 15 hundredths, so we add 2 zeros. And thousands, 9 and 6 are 15, 5 is 20, and 27 thousands, so we have 3 zeros. And then we add the partial sums. 2, 8, 7, 6, 0. Note that, as with all these alternative methods, there's extra writing, but remember that the point is not for speed, but it's to understand the counting system. Speed and shortcuts can come later. Also note, with the partial sums method, you don't have to worry as much about carries. There may be some down at this stage, but that would be all. Another alternative method is with expanded notation. In expanded notation, 976 can be represented as 900 plus 70 plus 6. And again, we add each unit separately. So in the ones, 8 and 6 are 14, plus 3 is 17. In the tens, 9 and 9 is 18, plus 7 is 25. Since it's tens, we add a 0. And now we do a partial sum. Gives us 267. And then we add the hundredths. 8 and 4 is 12, plus 9 is 21 hundredths, so we add 2 zeros. Then we do another partial sum, 2, 3, 6, 7. So note you're less likely to have to worry about carries here also. Here's an example with 4-digit numbers. So again, we add each separately. 2 6s are 12, 2 is 14, and 3 is 17. Tens, that's 8, 10, 14. This is tens, 1, 0. Now we do our partial sum, 157. Here, 10, 18, and since it's hundreds, we add 2 zeros. Then we do our partial sum. Then we go to thousands. 9 is 18, then 3 is 21, 8 is 29, and since it's thousands, 3 zeros. Now we do our partial sum. So there may be some carrying, but you can also just do counting up. And note that you can do these from right to left. So this is 29 gives us, and 1 gives us 30, then 9, 5, 7. So again, note that there's some extra writing, but the point is to understand the numbering system. Another alternative is column addition, where you add the units separately. So the ones column 6 and 4 is 10, plus 5 is 15. Tens column 10 plus 2 is 12 tens. Hundredths, 10 and 11. And then you regroup. These 10 here, these 10 ones become one group of 10, and 5 ones left. So now that gives us 13 tens. And next we regroup the tens. 10 tens gives you a group of 100. So we have a group of 100 plus 3 tens. So now we combine our our hundredths, which gives us 12 of them. And then we just regroup that 10 groups of 100 to a group of 1,000 for our final answer. This is column addition with 4-digit numbers. So 6 and 7 is 13, and 9 is 22. our tens, we have 8 plus 4 is 12 plus 9 is 21 tens. Note that we don't need zeros in this case. Our hundreds, 8 and 6 are 14, and 9 is 23. Here, 2 nines are 18, plus 2 is 20. So again, starting from the right, we regrouped. This 22 gives us 2 tens plus 2 ones. So we're going to have 23 tens. Then we regroup our tens. These 20 tens become 2 hundreds. And now we add up our hundreds. And then we regroup these hundreds. Each group of 100 becomes a group of 1,000. So each 10 hundredths becomes 1,000. And now we combine our thousands. Okay, and then we could have regrouped this over to the tens of thousands, but basically we can read the number as 22,532. So again, these alternative methods take a little more writing, and with columns of numbers you can have a lot of writing. But again, the point is to understand the numbering system, not to do tedious calculations for long columns of numbers. And if you want to do more practice with these methods, you can go to mathgalaxy.com. Thank you for listening.